Hello, this is Dr. Brown. In this video, we're going to go over the final exam practice that's on the website. I also urge you to take the other version of the final exam practice that is on D2L. Now, for the final, you will be able to take this formula sheet. This is sort of an updated one I just sent you. So you'll be able to use the formula sheet that also includes the normal distribution information. So let's get on with the practice final. Number one, use braces to write the members of the set or state that the set has no members. And the set we're talking about is the positive integer powers of 3. Well, that would be 3 to the 1 power is 3. 3 to the second power is 9. 3 to the third power is 27, and so forth and so on. You can see that that answer is C. The next one is we have this Venn diagram, describes the types of cookies in a bakery. Venn diagrams make it a lot easier to evaluate various quantities when you're talking about variables. We want to use it to determine how many cookies have neither chocolate chips nor walnuts. Well, we see pretty clearly the chocolate chips and the walnuts, and those that have both chocolate chips and walnuts, and the universal set as far as the cookies is concerned. The amount of number of cookies that don't have chocolate chips or walnut would be 7. So the answer is B. Now, number 3, write the negation of the proposition. No 5th graders play soccer. Now, if you could come up with at least one 5th grader plays soccer, that would negate the proposition that no 5th graders play soccer. So that is the negation of that statement. Now we have a truth table, and we want to figure out which of these truth tables represent R and not S. Okay. What we want to do is start out with R and not S. And so let's put R and not S. R would be T, true, true, false, false. And looking at S, which is true, false, not S would be false, true, false, true. So R and not S. We can figure that one out by looking at R and not S. In order for it to be true, both of them have to be true, so this would be false. This one would be true. This one would be false. And this one would be false. So the one that works here is C. False, true, false, false. Notice that this has false, true, false, false, but it's got P and not S, which was just thrown in there to maybe throw you off. So be careful with the answer that you pick. Number 5, if horses have 6 legs, then Benjamin Franklin was the first president of the U.S. The proposition is that if P, then Q, where P is horses have 6 legs, then Q, Benjamin Franklin was the first president. So if P is true, then Q must also be true. But here, P is false because horses don't have 6 legs. We don't have enough because the antecedent P is false. There's not enough evidence to prove that Q is false. So we assume it's true. Assume Q is true until we have more evidence. Now, when that evidence comes in, we could prove that Benjamin Franklin was not the first president of the United States. But just because the antecedent, horses have 6 legs, is false, we don't have enough evidence to prove that Benjamin Franklin was not the first president of the United States. So we pick true here. And we're waiting for further evidence. Number 6, determine whether the argument is inductive or deductive. The last 4 answers were false, therefore the next one will be false. Is an inductive based on observations that may or may not carry forward and be true, but that's something you might assume if the last 4 were false. This inductive argument is weak, but you might think that if the same thing happened on the previous 4, maybe it's going to happen on the next one. Number 7, a die with 6 sides is rolled. What's the probability of rolling a number less than 5? Well, you can roll a 1, 2, a 3, and a 4, and obviously a 5 and a 6. So the probability is 4 out of the 6, which is 2/3. So the answer is D. Determine whether the events A and B are independent. A balanced die is rolled twice. The event A is the sum of the two rolls is 8. Event B is the first roll comes up 3. Well, the first roll depends, well, the first roll influences the sum outcome. Because the first roll coming up 3 will influence the possibilities of the sum. So they're not independent. The two rolls are what you get on the second roll depends on what you got on the first roll, or the sum of the two. So it is not independent. You're dealt 2 cards without replacement from a shuffle deck of 52 playing cards. Find the probability that the first card is a king and the second card is a queen. Well, we have obviously 4 kings and 4 queens. The probability of getting a king on the first draw is 4 out of the 52. So this is the probability the first is a king. Then you have 51 cards left, and there are 4 queens. So the probability of getting 4 queens on the second draw is 4 out of 51. So the probability is equal to 4 over 52 is 1 over 13 times 4 over 51 equals 4 over 13 times 51 is 663. So this is a probability, so it's answer D. Of the 81 people who answered yes to a question, 11 were male. Of the 84 people who answered no to the question, 13 were male. If one person is selected at random from the group, what's the probability that the person answered yes or was male? Well, we need to put together a table here. And first of all, the answer. We know some answered yes and some answered no. The males were told that answered yes were 11. And there were females and then there was a total And we're told that of the 81 people who answered yes, that would be a total of 81 here that answered yes. And since there was a total of 81 that answered yes, there must have been 70 females. Of the ones who answered no, there were 13 males. And there was a total of 84 who answered no. So that leaves 71 females who answered no. So the total number of people who answered the question was 165. And the number who we want to find the probability that the person answered yes or was male. Well, the total number who answered yes were 81. And then, or was male, there were then 13 males who answered no. So the total who were answered yes or were males that answered no would be 13. So we got 94. So the probability is going to be 94 out of 165, which is equal to 0.5696, which we round off to 0.57, and the answer is C. Number 11, evaluate the factorial expression. We want 6 factorial divided by 4 factorial times 2 factorial. Well, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. And of course, 2 factorial is 2 times 1. So notice we can cancel out 4 times 3 times 2 times 1. And the 2 goes into the 6 3 times. So we get 15 as the answer. Answer D. In a certain lottery, 6 different numbers between 1 and 12 inclusive are drawn. And these are the winning numbers. How many different selections are possible? Well, that is just simply going to be a combination of 12 things taken 6 at the time. And for this particular one, I'm going to go ahead and bring up the calculator. I think you already know how to do this. Combination of 12 things taken 6 at a time. We put in 12, then hit probability and pick NCR, which is combinations of n things taken R at the time, and now put in the R, which is 6, and hit enter, and we get 924, which is answer A. Now, number 13 is a normal distribution problem. Scores on a test are normally distributed with a mean of 105 and a standard deviation of 18. What percentage of scores are greater than 141? The mean is 105. The mean plus one standard deviation is 123. And the mean plus two standard deviation is 141. And we want to find the percentage of scores that are greater than 141, which is two standard deviations. So let's go ahead and bring up standard deviation, which is on your sheet. This would be, the mean is 105. Mean first one standard deviation is 123. And the mean plus two standard deviations is 141. So we want to find the percentage of the data that is to the right of 141 would give us the probability and the percentage. So there's 100% total. There is 50% to the left. There would be 34% to between one standard deviation, or between the mean and one standard deviation. And there would be 13.5 between one standard deviation and two standard deviations. So to the left, we have 50, 34, and 13.5, which is a total of 97.5. So the to the right, which would be the percentage greater than two standard deviation, would be 100 minus 97.5, which is 2.5%. So the answer is C, 2.5%. Notice the way we got 13.5, we have 68% plus or minus 1, which puts 34 and 34. And 95% between minus two standard deviations and plus two standard deviations. So this part would be 47.5. So subtracting 34 from 47.5, you get 13.5. What is the type of sampling we're using here? Whether it's simple, random, stratified, systematic, or convenience. A market researcher selects 500 people from each of 10 cities. This would be stratified sampling. Number 15, we're doing a study. Identify the population that you're studying. The manufacturer of light bulbs wants to determine the average lifetime of its 75-watt light bulbs among 120 randomly selected 75 light bulbs. The average lifetime was 1,007 hours. What is the population? The population is all 75 light bulbs manufactured by the company, because the key thing is looking at the average lifetime of its 75-watt light bulbs, not anybody else's. So you wouldn't do all 75 light bulbs answer C is not the population, but a parameter. And the population would not be the 120 random selected. That's just a sample. Identify the variable as either qualitative or quantitative. The eye color of women playing softball would be qualitative. Number 17, find the range of the given data. The amount that Jeremy has saved in each of the last 6 months is shown below. The range is equal to the max minus the min. Well, the max that I see here is, be careful looking at the data, especially if there's a lot of data. This was pretty simple. The max is 612, and the minimum is 117. And that is equal to 495. So the answer is B, 495. Find the mode for the given sample data. Well, here again, we have just a few samples, so it's fairly easy to find the mode. Be careful to count everything up. It's pretty obvious that you've got 3 39s, and none of the other numbers are given more than 3 times, so the mode is going to be 39. We want to prorate the given expenses to find the monthly cost for this person. The food is $350 per month. And I'm going to go ahead and multiply by 12 and get per year. So 12 times 350 is $4,200 per year. The health insurance is $1,700 semi-annually. And that would be $3,400 per year. And then the car insurance is $700 per year, which is $700 per year. So we add up the total yearly and we get $8,300 per year, which is equal to 691.666 per month, which is rounded off to the nearest dollar is $692. Answer A. You invest $10,000 in an account that pays simple interest of 3% for 7 years. You want to find out the amount of interest over this period. The interest equal to the principal times the rate times the time, with the principal being $10,000, the rate being 0.03. Always remember to put the rate in decimal form, and times T, which is 7, multiply out, and you get $2,100, which is answer D. The next problem is basically identical. I equal PRT, still simple interest, with $13,000 times 0.02% or 0.02 is a rate. 2% times 17 equals $4,420. So the answer is D. Now we want to calculate the monthly payment for a home mortgage of $88,000 with a fixed APR 3.7% for 15 years. Well, you would bring up the payment formula, which is on your sheet, and the PV, present value, which would be the amount of the mortgage when you start out, $88,000. The rate is 0.037. N is the number of compounding periods, which is 12. We're talking about monthly payments, so it's 12 per year. And then the number of years is 15, T is 15. So plugging into the formula, you get 88,000 times 0.037 divided by 12 divided by 1 minus 1 plus 0.037 divided by 12 to the minus 12 times 15. Now I'm going to bring up the calculator and show you how I would do it. There are various ways to do it on various calculators. Well, I would first start out, because we're going to be doing division, and we're going to put 88,000 in. Got to be careful to check your work. Quite often you can make a simple error. I would do it twice. Now we're going to do another division, and it's going to be 0.037 divided by 12. And you need to put it in parentheses. In fact, you need to move the place for the parentheses to the right. Now you have it in parentheses. And now we're going to do the denominator, which is 1 minus parentheses 1 plus 0.037 and divided by 12. In fact, I'm going to go back. This works fine. I'm going to delete this and show you how you can put it in exactly how it's shown. So now we would introduce a division and get to 0.037 divided by 12. Now move this over and put the in parentheses, and now we're going to do an exponent. It's going to be minus 12 times 15 in the parentheses there. And now you can calculate it, and we get 637.775, which is 637.78 per month, which is answer A. When you're doing this on the test, I would check it twice. It helps a little bit to have a multiple choice test here. Number 23, we have a linear function. We want to answer the question below. You purchase a motorcycle for $9,090 if you purchase it, or you can lease it for putting down $610 and then paying $237 per month. Find an equation that describes how the cost of the lease depends on time. Well, L is going to be what we call the lease, and it's going to be, you're going to pay $610 up front plus $237 a month. That would be the slope of the linear function. And they're using a variable of m, it looks like, instead of t, which is fine. So this would be the equation, 627, 610 plus 237 m. And we want to know how long can you lease the motorcycle before you paid more than its purchase price. Well, let's set that equal to the purchase price, which is $90.90. So 237 m is equal to $90.90 minus 610. 237 m is equal to $84.80. And m is equal to $84.80 divided by 237 is equal to 35.78. So this is the exact amount in months of the lease, where the lease and buying it are equal. So 35 months, you are below the cost of outright purchase. So 36 months you're above. So the answer to the question is the one with 35 months. So the answer is C. Find the equation that represents the population of a town here. It has an initial population of 56,644. It grows at a rate of 2.6%. So R is 0.026. Create an equation of the form Q is a population equal the initial population Q naught times 1 plus R to the T. Well, this will be simply Q equals 56,644 times 1 plus 0.026 to the t power, and we get 5664, 56,644 times 1.026 to the t power. So this is exponential growth, obviously, and the answer is C. Evaluate the validity of the chain of conditionals. Premise, we assume this is true. If I pay my bills on time, then my credit will be good. Premise 2, if my credit is good, then I will become a movie star. If we assume that this is true, and this is true, then the conclusion, if I pay my bills on time, then I will become a movie star, is a valid conclusion. Of course, it all hinges on the fact that you'll become a movie star if your credit is good. Number 26, we want to rephrase the statement as a conditional proposition with the form if P then Q. The statement is attending practice is necessary for staying on the team. Well, this is pretty obvious that the answer is going to be if you stay on the team, which is P, which is Q, then you must attend practice. So the answer is B. If you stay on the team, then you must attend practice. Number 27 is another Venn diagram. It describes the optional features ordered by new telephone customers in a certain region. Use it to determine how many customers ordered call waiting. Well, here we have ones who ordered caller ID in this circle, and this would be call waiting. And we see 40 only call waiting and 36 he ordered both. So the total we're looking for those who wanted call waiting is 40 and 36 equals 76. Answer A. We need to determine whether the argument is inductive or deductive. Every coach must know his sport well. Steve Spurrier is a football coach. So Steve Spurrier knows football well. This is a deductive argument because we know that every coach must know his sport well. And if Steve Spurrier is a football coach, we must deduce that he knows football well. Number 21 or 29, we want to identify the population parameter in this study. It's not the population, but the parameter. A bank manager wants to know the average amount of time customers of the bank have to wait in line. 300 customers were polled and asked their average wait time at the bank. 27 of the 300 people were extremely dissatisfied with the amount of time they had to wait in line in recent months. Well, the parameter has got to be the average wait time for all the bank's customers because they're looking for their customers, not anybody else's. Okay. answer is D. We want to create, problem 30, a pie chart. Favorite food, Chinese, Indian, Mexican, and Thai. This is the number of responses. The total responses, if you add them all up, is 800. Now, for this particular problem, the Chinese percentage would be 230 over 800 is 0.2875, which is, if you round off to the nearest percent, is 29%. Now look at the possible choices, and you'll see that B is the one that has Chinese, 29%, and no others have that. So without doing every one of these, you can see that the answer is B. In some problems, you might have to do another one or two in order to identify which is the right one. Okay. Number 31, we want to find the median for the data given here. I'm going to just assume that you can do that. The answer is this, and in the next problem, I'm going to actually put the data in when we get, we'll calculate the 5-number summary. If you do this particular one, the calculator will give you the median, which is 4713.50. And I urge that you do that. On the next one, I'm going to show you exactly how we do this particular problem, put it in the calculator that we have. So if you have this calculator, we're going to clear it off, and we're going to enter the data. And here again, you've got to be very careful to enter the data. You hit data, and I'm going to hit data again, and I'm going to clear L1. And now I'm going to start entering the data. And that'll be 690, 606, 813. Takes a little while to do this, especially if you're pointing on the screen like I am. 728, 584, 481, 630, 537. You could fast forward on this if you want to. 537, 665, 685, 466, 561, 787, 509, and 826. That should be 16 data points, and it says it's 16. So we've entered them all. I'm going to go ahead and calculate, do second. Data, and we're going to do variable statistics. And we're going to do it on L1 with a frequency of 1. And we're going to hit calculate. And I'm going to assume that if I put the data in right, that the answers are here. I see 466, 549 for the Q1. The median is 634.5. The third quartile is 709. And the top maximum is 826. So it looks like we got it right. The answer is going to be D for the 5-number summary. Number 33, a restaurant offers 3-course meals with 3 types of salads, 7 different main courses, and 6 different desserts. How many different 3-course meals can be ordered? The number is going to be 3 times 7 times 6 equal 126. Now, among the contestants in a competition are 41 women and 27 men. If 5 winners are randomly selected, what is the probability that all will be men? Well, first of all, we need to know the total ways to select 5 out of 68. So the total ways to select 5 out of 68 total is going to be a combination of 68 taken 5 at a time. And you can do that in your calculator, as we've already shown you how to do, is 104,24128. Over 10 million. The total ways to select 5 men out of the 27 men is going to be a combination of 27 taken 5 at a time. And that's 80730. So the probability of selecting 5 men is going to be very small. It's going to be 80730 divided by a little more than 10 million. Which is 0.00774, which is answer A. And the 35th, just ignore the fact that I put the 34 down twice here. I think in the one that's on the website, it just has 34 once. Number 35 is a linear function. The pool record for the 100-yard freestyle back in 1990 was 47.3. The record falls a constant rate of 0.04 seconds per year. What does the model predict for the record in 2009? Well, if you let R be the rate, we know it starts off at 47.3 and goes down by 0.04 per year. So the rate in the year 2009 is going to be 47.3 minus 0.04. 2009, that is 19 years past 1990. So T is 19. And that is equal to 46.54. So the answer is B. There's the equation, and then there is what the record will be in 2009. And that is the practice final.